Everybody, welcome or welcome back to my channel. Today we'll be starting chemistry semester and exam preparation. So this is module 1 and this is not all the topics, it's just the first half of it. So I thought instead of making into long videos, I think even shorter videos would be quite helpful to even revise the only concepts required which is required. So I thought of making it into parts by parts. So today I'll be dealing with concentration cells. This is just the first video. The other videos also are coming up, and let's start quickly then. I'll just briefly tell the concepts, which is going to be sufficient hopefully. So concentration cells. So when you learn the different other single electropotential or Nernst equation, then you will galvanic cell. Then you understand more about how cells actually is happening. But I'll just tell you, in concentration cells, first you know that there are two half cells. There's electrode dipped in it, salt bridge. This is connected externally through a circuit, all of that. In the concentration cell, I'm telling you, both the electrodes are same and the solution also is same. If both the electrodes are same, both the solutions are also same, how do you think the electricity is going to be generated from the chemical reaction, because there is no driving force? So what is going to happen is that indeed both electrodes are same, both solutions are same, but the concentration of the solution is going to vary. It's going to act as a galvanic cell. It's going to act like an electrochemical cell, but because of the change in concentration of the solution, not because of difference in potential, because of the difference in concentration of the solution. So eventually potential will vary. Okay, let's not go into depth of it. So basically, just remember this much: two half cell. It's going to act like an electrochemical cell because the difference in concentration of the solution, as both the electrodes are same and both the solutions are also same. So then what's the driving force? As I told you, if there's no difference in potential, then the difference can be brought by changing the concentration of the solution, as I told you. So these cells are called as concentration cells. The difference in concentration of the solution acts as the driving force for the flow of electrons. But the question comes, how do we fix the anode and cathode? So anode was the one which had lesser potential back in that. So now anode will be the one which has lesser concentration. This will have more concentration. So anode is the one which has lesser concentration, cathode is the one which has more concentration. Let me show you an example quickly. Suppose this is CuSO4 solution. This also will be CuSO4 solution. This will be copper electrode, salt bridge, external circuit. Both will be copper. So there is no SRP as such because both of them are copper. This is anode. It's going to be 1 molar. This is cathode. This is going to be 2 molar. Anode, cathode. Anode will have lesser concentration. Anode will have lesser concentration than cathode. Now let us learn the Nernst equation for concentration cell. Okay. Nernst equation for concentration cell potential. A derivation. It's a very small derivation, not to worry. So the same example I will take. Copper electrode is there, salt bridge, external circuit. This is copper electrode, this is copper electrode, this is CuSO4, this is again CuSO4. Take this as M1, take this as M2. So what did we understand? Suppose I'm taking this as anode and then taking this as cathode. I would want my M1 to be lesser than M2. Okay. So now let's write the Nernst equation. First I'm going to write the Nernst equation for the cathode. So E cathode I will write E cathode equals to EC, that is equals to EC naught plus. Remember, some people get confused with minus. No, it's going to be plus. Okay, that I'll explain you more when I'm teaching other topics, but yeah, to keep it as plus now. EC naught plus 0.0591 by N log of Mn M2, right? Just write M2. We should write Mn plus, right? No, let's not confuse all of that, right? Just write M2 because cathode has what? M2. Similarly, E anode, that's going to be EA, that is equals to EA naught plus 0.0591 by N log M1. So now I want EC minus EA. That is no, 1 second. Cell potential, we want the concentration cell potential. That is going to be E cell, that is going to be EC minus EA, that is going to be EC naught minus EA naught plus 0.0591 by N log of M2 by M1. Log M2 minus log M1 is nothing but log of M2 by M1. And this, I told you, this is standard reduction potential, right? That's going to be 0 because both of them are same. So whatever is the potential of cathode minus again the potential of, whatever the potential of copper minus the potential of copper again will be what? 0 only. So E cell, the concentration cell is going to be 0.0591 by N log of M2 by M1. That is the final formula. Okay, that's a Nernst equation for concentration cell. So they might ask you what is a concentration cell. A concentration cell is an electrochemical or a galvanic cell which has same electrodes in both the half cell and same solutions in both the half cell. The only difference is that the concentration of the solution is going to be different. The driving force is going to be the difference in concentration of the solutions. The anode will have lesser concentration, means more diluted. Cathode is going to be more concentrated. The Nernst equation, first you're going to draw the diagram, then you're going to write E cathode, which is going to be EC, which is going to be EC naught plus 0.0591 by log M2. E anode similarly, which is going to be EA, it's going to be EA naught plus 0.0591 by log of M1. Then you're going to write E cell potential, which is going to be cathode minus anode. E cathode minus E anode. So that is going to be EC minus EA. So that is going to be EC naught minus EA naught plus 0.0591 by N log of M2 by M1. EC naught minus EA naught is going to be 0. So E cell is going to be 0.0591 by N log M2 by M1. That is it. Nothing is hard in this, right? So now let's quickly solve few numericals and we'll be done with this. So a silver concentration cell consists of 0.5 molar and 0.25 molar salt solution. Write the cell representation, cell reaction and cell potential. By seeing this, you have to understand this is going to be the anode and this is going to be the cathode. So let's write, it's a silver, so Ag, first cell representation, how are you going to write? Ag bar, Ag 0.25, Ag 0.5 plus 1, my bad, plus 1 bar Ag, not here, over here, Ag plus 1. Solution, right? Solution, the solution will have the plus 1, is all of that. So Ag bar Ag plus 1 0.25 bar the salt bridge Ag plus 1 0.5 bar Ag. If you didn't understand how to write this, I'll bring up the video where I want to set representation of that in the first. I should have technically done all of that first, but anyway I've just started off this, so yeah, I'll do that also, so then you understand better what is happening. But this is how you write it. Okay, now cell reaction. Ag will give Ag plus 1, which is 0.5 molar plus an electron. This is going to happen in the anode. What is going to happen in the anode? Oxidation. Oxidation is loss of electron. Sorry, my bad, 0.25. This one. Okay, this part is the anode part, this part is the cathode part. Okay, then in cathode, what's going to happen? It's going to accept electron. Gaining of electron is called reduction. That's going to happen there. So Ag plus 1 plus this plus 1 is going to be of 0.5 molar. It's going to accept the electron. It's going to become Ag. This is going to happen in cathode and this is the reduction. Okay, so overall reaction will be what? Ag plus 1 0.5 molar is going to give us Ag plus 1 0.25 molar plus Ag. Whatever is in opposite, like here electron is in opposite, will get cancelled. it should be in opposite sides of the arrow. This is right side arrow, this is left side arrow, so that will get cancelled. Here you can say AG, HG get cancelled, no, it won't get cancelled because it's a different concentration. That's why it's important to mention the concentration even in the cell reactions. This is fine. Now we have to calculate the cell potential. So that's going to be E cell equals 0.0591 by N log of M2 by M1. This you have to remember, M2 by M1. So 0.0591 by N. Ag means what? It's going to be 1. Log of M2. That's going to be 0.5 by 0.25. So let's use the calculator to solve this. So I am getting the answer as 0.01779 volts. The unit of cell potential is going to be volts. Okay. If they say both the concentration, if they have same concentration, then likely will not be a concentration cell, but that time the potential will be 0. Okay, it might be a trick question. Then both of the cell potential have same concentration also, same electrode also, same solution also, then the potential will likely be 0. If they're given one electrode, the concentration of one is 10 times more than the other, then the lesser one will be 1 and the anode will be 1 and the cathode will be 10. One more question let's do quickly. Question: a silver concentration cell potential is 0.0177 volt. Concentration cell potential. Okay, this is. If the cathode concentration is 0.5 molar, calculate the anode concentration. Now just now we have solved the reverse of it, so we might know, but how to solve we should understand. Okay, so E cell, here they have not asked all of the reaction potential, nothing. Actually potential we have to find, no reaction representation. 0.0591 by N log of M2 by M1. 0.0177 equals 0.0591. It's Ag, so 1, let's take it as 1. Log of, this is cathode by anode, correct? So it's going to be 0.5 by M1. So what first we can do is 0.0177 by 0.0591 I can do. That's going to be 0.2994 equals log of 0.5 minus log of M1. Now let me take log of 0.5. So 0.2994 plus 0.301 equals minus log M1. So I am getting log M1 as 0.0016. I might have made a mistake, I'll just check. Now we want M1. It's going to be plus. Okay, somewhere I made a mistake. Let me just quickly cross check. So what they have done is they have not separated like this. I think that's where I've done the mistake. So this is a very common mistake which I've done. So 0.0177 by 0.0591 equals log of 0.5 by M1. This is same. This is going to stay like this only. .2994 equals to log of 0.5 by M1. Till here it is correct. Okay. Now what we need to do is to remove this log, we have to take anti-log. To remove this log, we have to take anti-log. To take anti-log, you have to raise 10 power that. Did you understand? Don't ever take it separately. That's what we have understood by this mistake, because I was not getting the answer. I don't know if it's some other mistake, but I did not get the answer that way. So what did you understand by that? don't take it separately. So I have to take 10 power. To take antilog, remember 10 power 0.2994 equals 0.5 by m1. So 10 power 0.2994 1.9925 equals 0.5 by m1. So 0.5 by 1.9925. Yeah, so then I'm getting m1 as 0.25 molar, which is correct. So I'll try not to make the videos this longer, because for shorter topics this much time is not required. But anyway, we had numericals as well, so I hope this video was helpful. It's a very simple topic, nothing much. So see you in the next one. Bye bye.